June 19th, 1944. Philippine Sea, northwest of Guam. Vice Admiral Jisaburo Ozawa stood on the flag bridge of the aircraft carrier Taiho, watching the first wave of his strike force disappear into the morning sky. 430 aircraft, launched from 9 carriers, the accumulated strength of the Imperial Japanese Navy's reconstructed carrier force. Everything Japan had rebuilt after the disasters of Coral Sea and Midway 2 years earlier now committed to this single decisive battle. Ozawa had explicit orders. The fate of the empire rests on this one battle. Those were Admiral Soemu Toyoda's exact words. Stop the American carrier force approaching the Marianas, or Japan itself would lie naked to invasion within months. The admiral checked his watch. His strike aircraft would reach the American fleet in approximately 1 hour. He had calculated every advantage. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. His aircraft could operate at longer ranges than American planes. His land-based aircraft on Guam would coordinate with the carrier strike. His force would fight from upwind, allowing his planes to attack and land while the Americans struggled against headwinds. Mathematics and geography favored Japan. What Ozawa could not see, 500 miles to the east, would shatter every calculation the Imperial Japanese Navy had made about this war. 15 American aircraft carriers steamed in formation, their radar systems already tracking the incoming Japanese strike. Not the 7 carriers America had possessed at Pearl Harbor, not even the depleted force of 3 carriers that had fought at Midway. 15 fleet carriers, 9 of them Essex-class vessels that had not even existed when Japan struck Pearl Harbor 30 months earlier. The numbers told an impossible story. In 1941, Japan had laid down 1 new fleet carrier, the Taiho, beneath Ozawa's feet. That same year, the United States had laid down 5 Essex-class carriers. The Taiho had required 32 months to complete. The Essex, laid down less than 3 months before Taiho, was commissioned in just 20 months. By June of 1944, 17 Essex-class carriers had been completed. Japan had managed to commission exactly 1 purpose-built fleet carrier during the entire war. The transformation had begun in the planning offices of the Bureau of Ships in late 1939, when Commander Leslie Knisken was appointed Chief Design Officer. The timing was deliberate. The Washington Naval Treaty, which had constrained carrier construction since 1922, had expired in 1936. The Navy Expansion Act of May 19th, 1938 authorized dramatic increases in fleet strength. War clouds gathered over Europe and Asia. The United States Navy recognized it needed carriers, many carriers, and needed them quickly. Knisken assembled a design team unlike any previous naval architecture effort. Traditional ship designers worked in isolation, creating vessels based on established principles and historical precedent. Knisken coordinated specialists from across the maritime industrial complex, naval architects, aviation facilities experts, catapult and arresting gear companies, aviation service personnel, and most importantly, actual carrier pilots, all contributed to the design specifications. The aviators made demands that horrified traditional naval architects. They wanted rectangular flight decks with wide corners extending beyond the hull, creating overhang that conventional engineers insisted would fail structurally in heavy seas. They wanted those corners because aircraft needed every possible foot of deck space during landing approaches. Sharp turns killed pilots. Wide corners saved lives. The architects produced calculations demonstrating that unsupported deck corners would buckle under stress. The aeronautical specialists countered that occasional buckled decks during typhoons were acceptable losses compared to daily landing accidents from inadequate deck geometry. The rectangular flight deck was approved. Every previous American carrier had been constrained by international treaty limits. Essex would be designed to a single overriding requirement, fitting through the locks of the Panama Canal. The canal's dimensions dictated maximum beam. Everything else could scale around that physical constraint. The result was a vessel that displaced over 30,000 tons, 1/3 larger than the Yorktown-class carriers that had fought at Coral Sea and Midway. The design incorporated lessons written in blood across 2 years of Pacific combat. The hangar deck would not be the ship's strength deck. That structural weakness in earlier carriers had made them vulnerable to damage. Essex moved the primary strength deck below the hangar, protecting the ship's structural integrity from hangar deck fires and explosions. Aviation fuel systems received obsessive attention. Previous carriers had fuel lines running through multiple decks, creating fire hazards throughout the ship. Essex segregated fuel systems, armored fuel storage, and positioned lines away from critical spaces. The design assumed the ship would be hit, would catch fire, would take damage. The question was whether the ship would survive and continue fighting. The elevator arrangements reflected hard-earned operational experience. 3 elevators, one positioned at the deck edge rather than cutting through the flight deck. This seemingly minor change proved revolutionary. When the deck edge elevator lowered aircraft to the hangar, it opened deck space for other operations. Flight operations could continue with one elevator in use. Earlier carriers had to clear the flight deck completely when using centerline elevators. The design specification called for 90 aircraft, all of which could be spotted on the flight deck simultaneously for a single massive strike. This Sunday punch doctrine would transform carrier warfare. Previous carriers launched aircraft in waves as deck space allowed. Essex could launch its entire air wing in a single devastating attack. The anti-aircraft armament reflected the new realities of air warfare. 8 5-inch dual-purpose guns in twin mounts for long-range defense, 32 40mm Bofors guns in quadruple mounts for medium range, 46 20mm Oerlikon guns for close-range defense. The ship bristled with weapons designed to create a protective steel curtain around the carrier. Radar, that mysterious new technology that had barely existed when design work began, received dedicated spaces. The Combat Information Center, a revolutionary concept, would be positioned below the armored deck. Previous carriers scattered tactical information across multiple stations. Essex concentrated all sensor data, communications, and tactical decision-making in one protected space. The ship would fight as an integrated weapons system, not a collection of independent departments. Secretary of the Navy Frank Knox approved the final design in February of 1940. Within weeks, contracts were awarded to 5 shipyards, 7 carriers to Newport News Shipbuilding in Virginia, 4 carriers to Bethlehem Steel's Fall River Shipyard in Massachusetts. The New York Navy Yard, Norfolk Navy Yard, and Philadelphia Navy Yard would receive additional contracts. The program would eventually encompass 24 completed ships, the largest single class of capital ships in history. Construction began with the laying of Essex's keel on April 28, 1941, at Newport News. By December 7th, when Japanese aircraft struck Pearl Harbor, 5 Essex-class carriers were already under construction. The attack transformed the program from ambitious to desperate. Congress immediately appropriated funds for 19 additional carriers. The order books swelled to 32 vessels. The challenge was not design but execution. Building a 30,000-ton aircraft carrier traditionally required 3 to 4 years from keel laying to commissioning. The Yorktown-class carriers that fought at Midway had each taken approximately 3.5 years to complete. At that pace, the first Essex-class carrier would not join the fleet until late 1944. By then, Japan might have consolidated its Pacific conquests into an impregnable defensive perimeter. The shipyards transformed their operations using principles borrowed from Henry Kaiser's revolutionary Liberty Ship program. Prefabrication became the foundation of accelerated construction. Instead of building ships sequentially from keel to deck, the yards fabricated major sections simultaneously in specialized workshops. While one crew assembled the bow section in Building 3, another crew fabricated the stern section in Building 7. The engine room took shape in the machine shop, while the island superstructure grew in a separate facility. When sections reached completion, massive gantry cranes lifted them onto the building ways, where welding crews joined them into a complete hull. The approach required unprecedented coordination. Materials had to arrive at precise times. Steel plates from mills in Pennsylvania, turbines from manufacturers in New York, catapult mechanisms from specialized contractors, electrical systems from a dozen suppliers. Every component had to reach the right building at the right moment, or the entire schedule collapsed. Newport News Shipbuilding, as the lead yard, established procedures that other facilities would follow. The company operated 24 hours daily under floodlights. 3 shifts rotated through the facility, maintaining continuous construction that never stopped for darkness or weekends. The yard employed over 30,000 workers by mid-1942. Many of those workers had never built ships before. The maritime craft tradition, where skills passed from father to son across generations, could not supply sufficient labor for wartime production. The shipyards recruited from across America, hiring farmers, factory workers, and particularly women who flooded into industrial work as men shipped overseas. Training programs compressed years of apprenticeship into weeks of focused instruction. Workers did not need to know every aspect of ship construction. They needed to master specific, repeatable tasks. Welders learned to weld vertical bulkhead seams or horizontal deck plates or curved hull sections. Electricians learned to install specific wiring harnesses. Pipe fitters learned to assemble particular systems. The specialization proved devastatingly effective. By October of 1942, Newport News employed specialists who could execute complex tasks faster than traditionally trained craftsmen because they had performed those exact tasks hundreds of times. A welder who did nothing but vertical bulkhead seams for 6 months achieved speed and quality that exceeded a generalist welder who worked on various joints. Quality control became an obsession. Every weld received magnetic particle inspection. Critical structural welds underwent X-ray examination. Compartments received pressure testing. The Navy assigned resident inspectors who lived at the shipyards, examining work in progress rather than inspecting completed sections after problems were irreversible. The first Essex-class carrier completed in 19 months, rather than the traditional 3.5 years. USS Essex commissioned on December 31, 1942, 870 feet long, capable of 33 knots, carrying 90 aircraft and a crew of 2,600 men. The ship was not beautiful by traditional naval architecture standards. The rectangular flight deck with its wide corners looked ungainly. The forest of anti-aircraft guns created a cluttered appearance. The massive island superstructure seemed oversized. But Essex was not designed for beauty. The ship was engineered for a single purpose: launching and recovering aircraft in sustained combat operations while absorbing damage that would sink earlier carriers. USS Lexington, the second Essex-class carrier, commissioned in February of 1943, then Yorktown in April, followed by Intrepid, Hornet, Franklin, Ticonderoga, and Randolph in rapid succession through late 1943. The pace accelerated. By August of 1943, Essex and Yorktown had reached Pearl Harbor. The new carriers created immediate operational impact. Previous American carriers had operated individually or in pairs, constrained by numbers. With Essex-class carriers arriving monthly, the Navy could mass carrier power in ways previously impossible. Task Force 58 formed in January of 1944 under Vice Admiral Mark Mitcher. The force comprised 4 task groups, each centered on multiple carriers. Task Group 58.1 included 3 Essex-class carriers plus light carriers. Task Group 58.2 fielded 2 Essex-class carriers with escorts. The remaining task groups followed similar patterns. In total, Mitcher commanded 9 Essex-class carriers by June of 1944. The operational doctrine evolved to exploit this unprecedented carrier concentration. Previous carrier operations had been cautious affairs, preserving irreplaceable assets. With Essex-class carriers arriving every 6 weeks, the Navy could accept losses and maintain offensive pressure. The carriers no longer protected themselves first and attacked second. They attacked continuously, trusting their numbers and defensive systems to absorb casualties. The transformation of American carrier doctrine paralleled the transformation of American industrial capacity. In 1941, Japan possessed more carriers than America. By mid-1943, American carrier construction had achieved parity. By June of 1944, American carrier strength exceeded Japanese capacity by factors that Japanese naval planners found literally incredible. The mathematics were brutal. Japan had completed one purpose-built fleet carrier during the entire war. The Unryu-class carriers, Japan's attempt at mass production, planned for 14 ships. The Navy completed 3 in the fall of 1944, too late to effect combat operations. Those 3 ships displaced 17,500 tons each, lighter than Essex's 30,000 tons, carrying fewer aircraft with less armor protection. Japan's carrier construction struggled with fundamental resource constraints. The Taiho required 32 months to complete because Japan lacked sufficient turbine manufacturing capacity. The Unryu-class carriers used cruiser machinery because no carrier-specific turbines existed. The 3rd and 5th Unryu-class carriers received destroyer turbines, reducing their speed by 2 knots. The ships were compromise solutions built from whatever components could be scavenged. America's Essex-class carriers shared standardized components manufactured in dedicated industrial facilities. The Westinghouse turbines that powered every Essex-class carrier came from factories tooled specifically for carrier production. The Babcock and Wilcox boilers were identical across the class. Catapults, arresting gear, radar systems, fire control directors, all standardized, all mass-produced, all interchangeable between ships. The standardization enabled unprecedented operational flexibility. Pilots trained on one Essex-class carrier could operate from any other ship in the class. Maintenance crews familiar with Essex could work efficiently on Lexington or Intrepid. Spare parts fit any ship. Damaged vessels could be repaired using components stripped from ships undergoing overhaul. By spring of 1944, the industrial transformation was complete. Every 6 weeks, another Essex-class carrier commissioned and began working up for combat operations. The shipyards had achieved production speeds that traditional maritime experts had declared impossible. Newport News completed carriers in 16 months on average. The other yards matched or exceeded this pace. The arrival of Essex-class carriers fundamentally altered Pacific War strategy. Admiral Chester Nimitz no longer rationed carrier deployments, hoarding irreplaceable assets for decisive battles. The Central Pacific Offensive, which began with the Gilbert Islands in November of 1943, proceeded with confidence that carrier losses could be replaced faster than Japan could exploit any tactical victory. The Marshall's Campaign in February of 1944 demonstrated the new operational tempo. Task Force 58 struck Kwajalein, Eniwetok, Truk, and the Marianas in sustained operations that would have exhausted earlier carrier forces. The Essex-class carriers could maintain air operations continuously because the ships carried fuel and ammunition reserves that earlier carriers lacked. The carriers demonstrated remarkable survivability when Japanese forces counterattacked. Intrepid took a torpedo hit during the Truk strikes. The torpedo blew a hole in the hull, flooding compartments and killing 11 men. Earlier, carriers might have been forced to withdraw to Pearl Harbor. Intrepid's damage control parties sealed the breach, pumped the flooded spaces, and the ship continued operations for 2 more days before retiring for repairs. That resilience was engineered into every system. The subdivided hull design, copied from British carrier practices, created watertight compartments that contained flooding. The segregated fuel systems prevented single hits from creating ship-wide fires. The armored magazines ensured ammunition did not detonate when compartments flooded. Essex-class carriers could absorb damage that would have sunk Lexington at Coral Sea or Yorktown at Midway, and remain operational. The human element matched the engineering excellence. Damage control training emphasized that every sailor was a firefighter first and a specialist second. Crew drills practiced responding to simultaneous casualties in multiple locations. The Combat Information Center coordinated damage response, directing repair parties to critical areas while maintaining combat operations. The Japanese Naval Command watched the build-up with growing alarm and disbelief. Intelligence reports documented the arrival of new carriers with model numbers that seemed impossible. CV-9 Essex in August of 1943, CV-10 Yorktown 2 weeks later, CV-11 Intrepid in November. The numbers climbed steadily. By March of 1944, Japan faced CV-16 Lexington, CV-17 Bunker Hill, CV-18 Wasp, all operational. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Japanese naval officers who had studied American industrial capacity before the war recognized these production numbers validated every warning they had issued. America's shipbuilding capacity exceeded Japan's by factors of 10 or more. The massive steel mills of Pennsylvania could produce more steel in 1 month than Japan's entire annual steel production. The precision manufacturing capability that built automobiles now built carrier components with identical efficiency. But even those officers who understood American industrial strength struggled to accept the reality of 24 Essex-class carriers. The number seemed fantastical. The Imperial Japanese Navy had begun the war with 10 carriers, accumulated over 2 decades of construction. America was producing that many Essex-class carriers in a single year. The strategic implications were catastrophic. Japan's war plan had always assumed industrial capacity would favor them in the war's early years. Capture the resource-rich territories of Southeast Asia, establish a defensive perimeter, then dare America to attack fortified positions at costs America would not accept. The plan required that American industrial production could not compensate for battlefield attrition quickly enough to maintain offensive momentum. The Essex-class carriers shattered that assumption. American production was not compensating for losses. American production was creating carrier forces that exceeded Japan's total naval strength. The defensive perimeter strategy required defending dozens of island bases across thousands of miles of ocean. Japan could not concentrate sufficient forces at threatened points when American carriers could strike anywhere with overwhelming superiority. The Battle of the Philippine Sea would provide the ultimate test of this industrial disparity. Vice Admiral Ozawa's mobile fleet represented Japan's maximum carrier effort. 9 carriers, the accumulated strength of 2 years of reconstruction, 430 aircraft, crews hastily trained to replace the veterans lost at Coral Sea, Midway, and Guadalcanal. Against this force, Admiral Raymond Spruance deployed 15 carriers under Mitchell's tactical command. 905 aircraft. Crews rotated through comprehensive training programs that replaced combat losses with experienced pilots. The disparity in pilot quality alone would determine the battle's outcome, but the numerical superiority made Japanese defeat inevitable. The radar systems aboard Essex-class carriers detected Ozawa's strike aircraft 150 miles distant. Fighter directors in the combat information centers processed the radar data, calculating intercept vectors. Hellcat fighters launched to meet the threat 75 miles from the fleet. The Japanese aircraft flew into a calculated ambush created by technology and tactics that Japanese forces could not match. What followed became known as the Great Marianas Turkey Shoot. Commander David McCampbell of Essex led a fighter section that destroyed 5 Japanese aircraft in minutes. His wingmen accounted for 3 more. Across the fleet, similar scenes repeated. Inexperienced Japanese pilots flying obsolete aircraft met veteran American pilots flying superior Hellcats guided by radar to optimal intercept positions. The first Japanese strike launched 69 aircraft. 8 reached attack positions. 1 bomb hit the battleship South Dakota. The remaining 61 aircraft were destroyed. The second strike fared worse. 130 aircraft launched. Fewer than 20 survived. The third raid lost similar proportions. The fourth raid was decimated before reaching the fleet. By day's end, Japan had lost 315 of 430 carrier aircraft. An additional 50 land-based aircraft on Guam were destroyed. American losses totaled 29 aircraft. The exchange rate exceeded 10-1, but the material losses, devastating as they were, paled compared to the human losses. The 315 destroyed aircraft carried pilots and aircrew that Japan could not replace. The training pipeline that produced carrier pilots required 2 years of instruction. Japan no longer possessed 2 years of time or the fuel and aircraft to train replacement pilots. The submarines Albacore and Kavala compounded Japan's disaster. Albacore torpedoed Taiho, Ozawa's flagship. The carrier suffered internal explosions from ruptured fuel lines and sank 6 hours later. Kavala torpedoed Shokaku, a veteran carrier that had fought at Pearl Harbor. She sank within hours. Two of Japan's largest carriers lost not to American aircraft but to submarines that exploited Japanese anti-submarine warfare weaknesses. The Battle of the Philippine Sea ended Japanese carrier aviation as an effective fighting force. The mobile fleet retreated with 7 surviving carriers that lacked sufficient trained pilots and aircraft to conduct offensive operations. Japan would never again launch a major carrier strike. The remaining carriers would serve as decoys during the Battle of Leyte Gulf 4 months later, sacrificed to draw American attention, while surface forces attempted a desperate attack on invasion shipping. The Essex-class carriers had achieved exactly what their designers intended. They had concentrated overwhelming force, absorbed the enemy's best efforts, and maintained combat operations despite damage. Essex took no hits during the battle, but sister ships Bunker Hill and Wasp suffered minor damage from near misses and continued fighting. The production pipeline ensured that losses could be replaced faster than Japan could inflict them. 3 more Essex-class carriers commissioned during the summer of 1944. Princeton joined Task Force 38 in August. Shangri-La commissioned in September. Bonhomme Richard reached the fleet in November. The conveyor belt of American industrial production delivered carriers faster than combat consumed them. Japanese commanders recognized they faced mathematical defeat. No tactical brilliance, no operational innovation, no strategic defensive position could compensate for an enemy that could absorb any losses and return stronger. The American carriers were not superior individually. Essex-class carriers were not technological marvels. They were industrial products, manufactured using standardized components and mass production techniques. That was precisely the point. America had transformed carrier construction from custom shipbuilding into industrial manufacturing. The ships were not beautiful. They were adequate, and adequate multiplied by 24 defeated perfection multiplied by 9. The final tallies of the Battle of the Philippine Sea documented the transformation. Japan lost 3 fleet carriers, over 600 aircraft counting land-based losses, and most critically, the trained air crews that could not be replaced. American lost no carriers, 29 aircraft in combat, and 80 additional aircraft lost to fuel exhaustion during maximum range strikes on the retreating Japanese fleet. Those losses were painful but absorbable. The human cost illuminated the battle's significance. Japan lost approximately 3,000 naval personnel, most of them irreplaceable pilots and aircrew. American casualties totaled 109 killed and 43 wounded. The exchange rate exceeded 25-1. Vice Admiral Ozawa's remaining carriers retreated to Japanese home waters, where they would sit largely immobile for lack of fuel, aircraft, and trained pilots. The mobile fleet had ceased to exist as an offensive weapon. The carrier force that had struck Pearl Harbor, that had dominated the Pacific for 6 months, that had remained a threat throughout 1943, was now reduced to hollow shells carrying inadequate air groups flown by minimally trained pilots. The Essex-class carriers proceeded to support the amphibious assaults on Saipan, Tinian, and Guam. The Marianas campaign concluded successfully, providing bases for B-29 bombers that would systematically destroy Japan's remaining industrial capacity. The carriers then turned their attention to the Philippines, supporting MacArthur's return in October of 1944. Throughout these operations, the Essex-class carriers demonstrated capabilities that previous carriers could only approximate. They maintained sustained air operations for weeks at a time. They absorbed kamikaze hits that would have sunk earlier carriers. They provided air cover for amphibious landings while simultaneously striking enemy bases hundreds of miles distant. The kamikaze threat, which emerged during the Philippines campaign, tested carrier survivability to limits the designers had not anticipated. Franklin took 2 kamikaze hits off Leyte in October, suffering extensive damage and casualties but remaining afloat. Intrepid absorbed 4 kamikaze hits between October and November. The ship returned to combat operations after each attack, demonstrating the resilience that standardized damage control and procedures created. The ultimate test came on March 19, 1945, when Franklin, operating off Japan, took 2 bomb hits that ignited massive fires and explosions in the hangar deck. Over 700 men died. The ship nearly capsized from flooding during firefighting operations. But Franklin survived, limped to Pearl Harbor under her own power, and eventually returned to the United States. No previous carrier could have survived that scale of damage. The kamikaze attacks revealed both the strengths and limitations of Essex-class carrier design. The unarmored flight deck, a weight-saving decision that horrified British naval architects, proved vulnerable to bomb penetration. But the subdivision below the flight deck, the segregated fuel systems, and the comprehensive damage control training allowed the ships to absorb catastrophic damage and survive. British carriers with armoured flight decks suffered less initial damage from kamikaze hits, but sustained deeper structural damage when bombs penetrated to interior spaces. The British approach prevented flight deck damage but risked magazine explosions when hits reached interior compartments. The American approach accepted flight deck damage in exchange for protecting vital spaces below. The debate about armoured versus unarmoured flight decks would continue for decades, but the operational reality was undeniable. Essex-class carriers maintained higher sortie rates than British carriers because they could repair flight deck damage quickly using wooden planking and portable equipment. British carriers with damaged armoured decks required shipyard repairs. By June of 1945, the Essex-class carriers dominated the Pacific. Task Force 38, successor to Task Force 58, comprised 9 Essex-class carriers plus light carriers. The force launched strikes against Japanese home islands with impunity. Japanese defensive forces, reduced to kamikaze tactics and hoarded aircraft waiting for invasion, could not challenge American air superiority. The final carrier strikes of the war came in July of 1945. Task Force 38 launched Operation Sinking, the systematic destruction of remaining Japanese naval vessels in home ports. The carriers targeted Kure Naval Base, where Japan's surviving carriers lay at anchor, immobilized by fuel shortages and lack of trained pilots. On July 24th, over 1,300 sorties struck Kure and surrounding installations. The carrier Amagi, completed just 9 months earlier, took multiple hits and capsized in shallow water. The carrier Katsuragi suffered devastating bomb damage that left her non-operational, though technically afloat. The few surviving Japanese carriers ended the war as burning hulks or immobilized relics. The Essex-class carriers had achieved complete strategic victory. They had destroyed Japan's carrier force, dominated the sea approaches to the home islands, and provided the air power that made amphibious operations possible across 5,000 miles of Pacific Ocean. The industrial production that created 24 Essex-class carriers in 4 years had determined the war's outcome as decisively as any tactical victory. The human stories behind these statistics revealed the transformation's true nature. Commander Leslie Kniskon, the design officer who coordinated the Essex-class specifications, never achieved fame beyond naval architecture circles. His contribution, creating a carrier design that could be mass-produced without sacrificing combat effectiveness, determined the Pacific War's outcome more than individual battles. The 30,000 workers at Newport News Shipbuilding, most of whom had never built ships before 1941, constructed 7 Essex-class carriers between 1942 and 1945. Their specialized training and standardized procedures enabled construction speeds that traditional craftsmen considered impossible. The damage control parties aboard Franklin, Intrepid, and other carriers that absorbed kamikaze hits represented the final element of the Essex-class success. The ships were engineered for survivability, but human courage and training transformed engineering into operational reality. When fires raged through hangar decks and explosions threatened magazines, the damage control crews who flooded compartments, established firefighting boundaries, and maintained watertight integrity kept their ships alive. The strategic vision that created the Essex-class program deserves recognition alongside tactical victories. The decision to design carriers unconstrained by treaty limits, to engineer for mass production rather than individual excellence, to standardize components across 24 ships. These choices were made in 1939 and 1940, before Pearl Harbor made them urgent necessities. The shipyard coordination that delivered carriers every 6 weeks from mid-1943 through 1945 represented industrial management achievements equal to Liberty ship production. 5 shipyards on the East Coast, building to identical specifications using standardized components, maintained synchronized production schedules while incorporating design improvements learned from combat experience. The design modifications implemented during production illustrated the program's flexibility. The first 10 carriers, called short-hull Essex, featured flush bows. Combat experience revealed these bows were vulnerable to storm damage. The remaining 14 carriers, beginning with Ticonderoga in May of 1944, incorporated extended bows with 12 feet of additional length. The clipper bow provided better seakeeping and additional space for anti-aircraft guns. The modifications continued throughout production. Radar systems improved constantly, each carrier receiving upgraded equipment as technology advanced. Increased as kamikaze threats materialized. The Combat Information Center layout evolved based on operational feedback. By war's end, no 2 Essex-class carriers were truly identical, despite standardized basic design. This ability to incorporate improvements while maintaining production schedules demonstrated sophisticated program management. Traditional shipbuilding modified designs between ships, not during construction. The Essex-class program implemented running changes, modifying ships under construction to incorporate lessons from recently completed vessels. The production statistics documented industrial achievement that remains impressive 80 years later. 24 carriers completed between 1942 and 1950. Total displacement, 720,000 tons. Average construction time, 18 months from keel laying to commissioning. The fastest construction, achieved on multiple vessels, reached 14 months. Labor efficiency improved dramatically as workers gained experience. The first carriers required approximately 1.1 million worker hours to complete. By late 1943, construction required approximately 700,000 worker hours per ship. The learning curve effect, combined with improved procedures and better materials coordination, accelerated production continuously. Cost efficiency matched schedule improvements. The first Essex-class carriers cost approximately $78 million each in 1942. By 1944, costs had fallen to approximately $70 million, despite rising wages and materials prices. The savings reflected standardization benefits and production efficiency gains. Each Essex-class carrier provided remarkable value measured in combat capability. The ships displaced 30,000 tons fully loaded and carried 90 aircraft. They could operate for 15 to 20,000 nautical miles at 15 knots before refueling. The Westinghouse turbines generated 150,000 shaft horsepower, providing sustained 33 knot speeds in combat operations. The defensive armament evolved continuously. The original design specified 8 5-inch guns and approximately 60 smaller anti-aircraft weapons. By 1945, carriers entering service carried 12 5-inch guns and over 100 anti-aircraft weapons. The ships had become mobile anti-aircraft platforms as potent as the aircraft they carried. Aircraft capacity defined the carrier's true power. 90 aircraft constituted a small air force capable of striking targets 200 miles distant with devastating effect. A typical air wing comprised 36 Hellcat fighters, 36 Helldiver dive bombers, and 18 Avenger torpedo bombers. This balanced force could establish air superiority, attack surface targets, and conduct anti-submarine operations simultaneously. The operational flexibility that 90 aircraft provided transformed naval warfare. Previous carriers with smaller air wings had to choose between fighter protection and strike capability. Essex-class carriers maintained continuous combat air patrol while launching full strike packages. The ships could defend themselves and attack enemies simultaneously, a capability no previous carrier possessed. The pilot training pipeline that supplied these air wings represented an achievement parallel to the carriers themselves. The United States trained approximately 60,000 naval aviators during World War II. The training program, concentrated in facilities across the southern United States, produced pilots in 8 to 12 months of intensive instruction. Japan's training program required 2 years to produce carrier-qualified pilots. As the war progressed, Japan reduced training time to as little as 6 months, producing pilots who lacked the skill to survive combat against experienced American aviators. The Battle of the Philippine Sea demonstrated the consequences. Well-trained American pilots flying superior aircraft from well-designed carriers destroyed Japanese air groups that outnumbered them locally, but lacked training and equipment quality to compete. The post-war careers of Essex-class carriers extended their influence for decades beyond 1945. When World War II ended in August, 17 Essex-class carriers were in commission. 7 more were in various stages of construction. The Navy completed 6 of these post-war, bringing total Essex-class production to 24 ships. 2 carriers under construction, Reprisal and Iwo Jima, were scrapped incomplete. 6 ordered carriers were cancelled before construction began. The Korean War, beginning in June of 1950, validated the decision to maintain Essex-class carriers in active service. 11 carriers participated in Korean operations, providing air support for ground forces and conducting strikes against North Korean targets. The carriers proved their versatility, operating in roles their designers had not anticipated. The modification programs of the 1950s transformed Essex-class carriers for jet aircraft operations. The SCB-27 program, beginning in 1947, upgraded 8 carriers with reinforced flight decks, improved catapults, and enhanced arresting gear. These modifications enabled the ships to operate early jet fighters and attack aircraft. The SCB-27 Ampères program, applied to 8 additional carriers starting in 1951, incorporated more extensive changes, including removal of the forward 5-inch guns to provide additional flight deck space. The ships received angled landing decks, a British innovation that revolutionized carrier operations by allowing simultaneous launch and recovery operations. The SCB-125 program, implemented in the late 1950s, added enclosed hurricane bows to carriers that had suffered storm damage during Pacific typhoons. The modifications vindicated the naval architects who had predicted in 1939 that rectangular flight decks would buckle in heavy seas. The enclosed bows prevented the structural damage that several carriers had experienced. The Vietnam War represented the 3rd major conflict for Essex-class carriers. 12 ships participated in Vietnam operations between 1964 and 1973. 4 operated as attack carriers, launching strikes against North Vietnamese targets. 8 operated as anti-submarine warfare carriers, protecting fleet units from submarine threats. The attack carriers demonstrated remarkable adaptability. Ships designed to operate propeller-driven aircraft from World War II successfully operated jet aircraft 3 decades later. USS Oriskany, commissioned in 1950, conducted combat operations off Vietnam until 1975, launching A-4 Skyhawk and F-8 Crusader jets from a flight deck designed for much lighter propeller aircraft. The limitations became apparent as aircraft grew heavier and faster. The F-4 Phantom and A-6 Intruder, mainstays of larger carriers, were too heavy for Essex-class operations. The ships could not generate sufficient catapult power or provide adequate landing area for these advanced aircraft. The carriers remained capable but constrained platforms. The anti-submarine warfare role extended Essex-class service lives into the 1970s. Conversion to CVS configuration included installation of bow-mounted sonar, specialized ASW aircraft and helicopters, and enhanced submarine detection equipment. The carriers operated S-2 tracker aircraft and SH-3 Sea King helicopters, providing protection for carrier battle groups and convoys. The space program provided an unexpected mission for Essex-class carriers. Several ships served as recovery vessels for Mercury, Gemini, and Apollo missions. USS Hornet recovered the Apollo 11 astronauts after their moon landing in July of 1969. The first steps on Earth by Neil Armstrong, Buzz Aldrin, and Michael Collins after returning from the moon occurred on Hornet's flight deck. The final Essex-class carrier in active service was USS Lexington, which operated as a training carrier from Pensacola, Florida, from 1962 to 1991. The ship provided deck landing experience for naval aviation cadets for 29 years, training thousands of pilots who would serve throughout the Cold War and beyond. The decommissioning of Lexington in November of 1991 marked the end of an era that had begun 50 years earlier when Essex commissioned. The class had served continuously from World War II through the Cold War, participating in every major American military operation for half a century. No other warship class in history achieved such sustained operational relevance. 4 Essex-class carriers survive as museum ships, preserved to honor their service and educate future generations. USS Yorktown in Charleston, South Carolina, USS Intrepid in New York City, USS Hornet in Alameda, California, USS Lexington in Corpus Christi, Texas. These ships welcome millions of visitors annually, providing tangible connection to the naval warfare that shaped the 20th century. The technological legacy of the Essex class extends beyond the ships themselves. The design innovations pioneered in these carriers influenced every subsequent American carrier. The deck-edge elevator, controversial when introduced, became standard on all future carriers. The Combat Information Center concept evolved into the sophisticated combat direction systems aboard modern carriers. The standardization principles that enabled mass production of Essex-class carriers influenced military procurement for decades. The concept of designing weapons systems for production efficiency rather than maximum individual performance became foundational to American military-industrial policy. Complex systems that could not be mass-produced, regardless of their theoretical superiority, were rejected in favor of adequate systems that industry could deliver in quantity. The damage control procedures developed aboard Essex-class carriers remain relevant in modern naval operations. The emphasis on comprehensive crew training, subdivision of spaces, and redundant systems informs contemporary ship design. The carriers demonstrated that survivability resulted from systematic engineering and training, not merely armor protection. The strategic lessons proved equally enduring. The Essex-class program demonstrated that industrial capacity could be decisive in modern warfare. The side that could build weapons faster than enemies could destroy them possessed overwhelming advantage regardless of tactical outcomes. Japan won most early battles but lost the production war catastrophically. The program also validated the importance of long-term planning. The design work that began in 1939, the contracts awarded in 1940, the construction that started in 1941, all occurred before Pearl Harbor made carrier construction urgent. The foresight to begin the program when peace still seemed possible determined the war's outcome years later. The human dimension of the Essex-class story deserves particular emphasis. The 30,000 shipyard workers at Newport News, the designers at Bureau of Ships, the damage control parties aboard Franklin, the pilots who flew from these decks, all contributed to achievements that transcended individual capabilities. The Essex-class carriers succeeded because thousands of people, most of them young and inexperienced in 1941, learned to perform complex tasks with excellence under desperate pressure. The women who worked in the shipyards, welding hull sections and installing electrical systems, challenged fundamental assumptions about industrial labor. The wartime necessity that brought women into shipbuilding demonstrated that complex manufacturing required training and organization, not gender-specific capabilities. The lessons learned during Essex-class construction influenced post-war industrial employment patterns. The minority workers who found skilled employment in shipyards, operating cranes, fitting pipes, and supervising construction crews, experienced opportunities that peacetime employment patterns had denied. The integration of shipyard workforces during wartime, driven by labor shortages rather than social policy, demonstrated capabilities that segregation had suppressed. The experience planted seeds for civil rights changes that would transform America in subsequent decades. The pilots who flew from Essex-class carriers came from every state, every background, united by intensive training that transformed civilians into naval aviators in months. The flight training pipeline that produced these pilots, the maintenance crews that kept aircraft operational, the ordnance teams that armed planes for strikes, all represented systematic approaches to complex operations that would influence military training for generations. The Essex-class carrier's greatest contribution was demonstrating that industrial democracies could mobilize resources and human capital with effectiveness that authoritarian regimes could not match. Japan's military leadership had calculated that American society, divided and individualistic, could not sustain the collective effort required for industrial total war. The Essex-class program proved that calculation catastrophically wrong. The United States designed, built, and operated 24 fleet carriers, while simultaneously building hundreds of escort carriers, thousands of aircraft, and millions of tons of support shipping. The industrial mobilization exceeded any peacetime economic activity in scale and coordination. The achievement required cooperation between government, industry, and labor that authoritarian systems attempted to impose through coercion, but democratic systems achieved through coordination. The comparison between American and Japanese carrier construction illuminated fundamental differences in industrial organization. Japan's centralized planning struggled to coordinate resources effectively. Shipyards competed for materials rather than sharing resources. The Navy and Army maintained separate industrial bases, duplicating facilities and creating shortages. Civilian industry received low priority for materials needed to support carrier construction. America's industrial mobilization, though far from perfect, achieved coordination through market mechanisms and government oversight that Japanese central planning could not match. Steel producers, shipyards, component manufacturers, and assembly facilities synchronized operations through contracts that specified delivery schedules and quality standards. Government priorities allocated scarce materials, but competitive bidding ensured efficient production. The result was visible in carrier construction statistics. Japan completed 4 fleet carriers between 1941 and 1945. America completed 17 Essex-class carriers, plus numerous light carriers and escort carriers during the same period. The disparity was not 10-1 or even 15-1. Counting all carrier types, American production exceeded Japanese production by factors approaching 30-1. The technological comparison favored America less dramatically but significantly. Essex-class carriers were not technological marvels. They used conventional steam turbines, traditional hull construction, and proven aviation systems. The genius was integration and production engineering, not revolutionary technology. Japan's Taiho incorporated armored flight decks and sophisticated damage control, innovations Essex lacked. But Taiho took 32 months to build, and only one was completed. Essex took 23 months to build, and 17 entered service before war's end. The operational comparison proved decisive. Japanese carriers operating with inadequate logistics support, insufficient fuel reserves, and hastily trained pilots could not sustain combat operations. Essex-class carriers with comprehensive logistics support, vast fuel capacity, and well-trained air wings maintained continuous offensive operations for months. The difference determined the Pacific War's outcome. Vice Admiral Ozawa's reaction to the Battle of the Philippine Sea, recorded in post-war interviews, captured Japanese recognition of industrial defeat. He had known intellectually that American production exceeded Japanese capacity, but confronting 15 American carriers, when his intelligence had predicted 8, revealed that intellectual knowledge differed from visceral understanding. The war was lost not in tactical engagements, but in shipyards, training facilities, and industrial plants that Japan could not match. The German naval observers who witnessed American carrier operations in late 1944 reported similar conclusions to their superiors. The technical reports, captured after Germany's defeat, documented German amazement at American carrier numbers and operational tempo. The reports noted that individual American carriers were not superior to German designs for carriers that were never built, but American carriers existed in numbers that made design comparisons irrelevant. The Soviet Union drew perhaps the most consequential lessons from Essex-class carrier operations. Soviet naval planners studying the Pacific War concluded that carrier-based aviation had replaced battleships as the decisive naval weapon. The Cold War carrier competition that developed after 1945 originated in Soviet recognition that Essex-class carriers had enabled American Pacific victory. The irony was that Soviet naval strategy emphasized submarine warfare designed to counter American carrier dominance, exactly the strategy Japan should have pursued but never effectively implemented. Japanese submarines wasted their potential attacking warships rather than the logistics vessels that sustained American advances. Soviet submarines in Cold War planning targeted the supply lines that Essex-class carriers depended upon. The Essex-class carriers influenced American naval strategy through the Cold War and beyond. The concept of carrier battle groups, centered on a carrier protected by screening vessels, originated in Essex-class operations. The integration of carriers with amphibious forces, developed during Pacific Island campaigns, became doctrine for subsequent operations. The emphasis on maintaining multiple carriers to ensure continuous presence derived from Essex-class experience, demonstrating that numbers mattered more than individual ship capability. The transition from Essex-class carriers to the supercarriers that replaced them illustrated both continuity and change. The Forrestal-class carriers, beginning construction in 1952, displaced 81,000 tons, nearly 3 times Essex displacement. But the operational concepts, organizational structures, and tactical doctrines developed aboard Essex-class carriers transferred directly to the larger ships. The debate about carrier survivability, sparked by kamikaze attacks on Essex-class carriers, continued through subsequent carrier designs. Should carriers emphasize armor protection, accepting reduced aircraft capacity, or should they maximize aircraft numbers, accepting vulnerability? The American choice, maintaining the Essex-class philosophy of unarmored flight decks and comprehensive damage control, reflected confidence that properly designed carriers could absorb damage and continue fighting. That confidence proved warranted. USS Forrestal suffered catastrophic fire in 1967 that killed 134 sailors and destroyed 21 aircraft. The damage control procedures pioneered on Essex-class carriers saved Forrestal from sinking. The ship returned to service after repairs, validating the design philosophy that emphasized survivability through subdivision and crew training rather than armor. The Essex-class carrier's final legacy was demonstrating that adequate designs produced in quantity defeated superior designs produced in small numbers. Japan's Taiho was arguably a better carrier than Essex individually. The armored flight deck provided protection Essex lacked. The damage control systems were more sophisticated. The aviation facilities were more advanced. None of this mattered because only 1 Taiho entered service compared to 17 Essex-class carriers by war's end. This lesson resonated through subsequent military programs. The German Tiger tank was superior to the American Sherman tank in armor, firepower, and protection. But America built 50,000 Shermans while Germany built less than 2,000 Tigers. The Shermans won through numbers and logistic support that Tigers could not match. The Soviet T-34 demonstrated the same principle on the Eastern Front, defeating superior German tanks through mass production. The principle extended beyond weapons to entire military forces. The Allies won World War II not through tactical brilliance or strategic genius, though both contributed, but through industrial mobilization that outproduced Axis powers by overwhelming margins. The Essex-class carriers epitomized this approach. They were good enough carriers built in sufficient numbers to enable victory. The human stories behind the statistics provide perspective on what the numbers meant. The young pilot who landed on Essex in August of 1943, having trained for 8 months at facilities across the southern United States, was part of an industrial system that produced pilots faster than Japan could shoot them down. His survival depended not on individual skill, though that mattered, but on numerical superiority that ensured American air groups outnumbered Japanese forces in every engagement. The damage control sailor who fought fires aboard Franklin in March of 1945, preventing the ship from sinking despite catastrophic damage, was executing procedures developed through systematic analysis of combat damage aboard earlier carriers. His courage was personal, but his effectiveness derived from training and equipment that reflected organizational learning across the entire carrier force. The shipyard worker at Newport News who welded hull sections in 1943, one of thousands performing similar tasks, contributed to capabilities that individual builders could not achieve. The standardization that made his work interchangeable with workers at other yards enabled production speeds that custom construction could never match. These individual stories, multiplied across hundreds of thousands of people, created the industrial achievement that the Essex-class carriers represented. The ships themselves were steel and machinery, impressive but ultimately comprehensible. The organizational systems that designed, built, operated, and sustained these ships represented human achievement of a different order entirely. The Essex-class program succeeded because it aligned every element of the industrial and military system toward a single objective, providing the fleet with carrier capability in quantity and quality sufficient to defeat Japan. The design satisfied operational requirements while permitting mass production. The construction employed standardization and specialization to maximize efficiency. The training produced crews who could operate and maintain complex ships effectively. The logistics sustained operations across thousands of miles of ocean. The comparison to Japan's carrier program revealed the consequences of systematic failure. Japanese design emphasized individual ship capability over production efficiency. Construction used custom methods that prevented rapid building. Training could not replace combat losses quickly enough. Logistics struggled to provide fuel and supplies to widely dispersed forces. Each element of the system failed to integrate with others, creating cascading weaknesses that tactical skill could not overcome. The Battle of the Philippine Sea demonstrated the cumulative impact of these systematic differences. Vice Admiral Ozawa commanded excellent ships and brave crews. His tactical plan was sound. His execution was professional. None of this mattered because the systemic advantages of American industrial organization had created numerical and qualitative superiority that tactics could not overcome. The 15 American carriers that Ozawa faced on June 19th, 1944, represented 3 years of systematic industrial mobilization. The 9 Essex-class carriers among them embodied design decisions made in 1939, construction that began in 1941, and operational experience accumulated across 2 years of combat. The system that produced these ships had learned from mistakes, incorporated improvements, and scaled production to levels that Japan could not approach. The aftermath of the battle validated the industrial strategy. Japan lost 3 carriers and could not replace them. America lost no carriers. If Ozawa had sunk 3 American carriers, 3 more Essex-class carriers would have joined the fleet within weeks to replace them. The mathematics of attrition favored the side that could replace losses faster than enemies could inflict them. This was the ultimate lesson of the Essex-class carriers. Naval warfare in the industrial age would be decided not by ship-to-ship combat, but by the industrial bases that produced ships faster than combat could destroy them. Japan entered the war with superior carriers and better-trained pilots. By mid-1943, American carriers outnumbered Japanese carriers. By mid-1944, American superiority was so overwhelming that tactical outcomes no longer mattered. The 24 Essex-class carriers built between 1942 and 1950 constituted the largest class of capital ships in history. This record will likely never be broken. Modern carriers cost billions of dollars each and take 5 to 7 years to build. The United States currently operates 11 carriers total, all nuclear-powered supercarriers that dwarf Essex-class ships in size and capability. But measured by impact on naval warfare, the Essex-class carriers remain unmatched. They enabled American victory in the Pacific, demonstrated the decisiveness of industrial mobilization, and established carrier-based aviation as the dominant form of naval power for the remainder of the 20th century. Every carrier operation since 1945, from Korea to Vietnam to the Persian Gulf, built on doctrines and procedures developed aboard Essex-class carriers. The 4 museum ships that survive provide tangible connection to this history. Visitors walking the flight decks of Yorktown, Intrepid, Hornet, or Lexington experience the spaces where the Pacific War was won. The cramped ready rooms where pilots received mission briefings, the narrow passageways connecting compartments, the massive flight deck stretching nearly 900 feet, all remain largely as they were 75 years ago. These preserved ships serve as monuments to the organizational achievement they represent. The Essex-class carriers succeeded not because they were miraculous machines, but because they were adequate machines produced in overwhelming numbers. They proved that industrial democracies, when properly mobilized, could outproduce authoritarian states decisively. They demonstrated that victory in industrial warfare required not merely fighting well, but also building faster than enemies could destroy. The shipyard, workers, the damage control parties, the pilots, the designers, all the thousands of people who contributed to Essex-class success, achieved something that transcended individual heroism. They created a systematic advantage so overwhelming that tactical defeats became irrelevant and strategic victory became inevitable. That is the enduring legacy of the Essex-class carriers, not the ships themselves, most of which were scrapped decades ago, but the demonstration that organized human effort, applied systematically over sustained periods, could achieve results that seemed impossible when the effort began. In 1939, the idea of building 24 30,000-ton carriers in 5 years would have seemed fantasy. By 1945, it was accomplished reality. The Japanese commanders who faced these carriers understood they had not been defeated by superior tactics or better weapons, but by an industrial system they could not match. American shipyards built carriers faster than Japanese forces could sink them. American training programs produced pilots faster than combat could consume them. American logistics sustained operations that Japanese supply systems could not support. The Pacific War was won in the shipyards of Newport News, Norfolk, New York, Philadelphia, and Quincy, as much as on the battlefields of Saipan, Iwo Jima, and Okinawa. The Essex-class carriers carried the war to Japan's doorstep and made invasion unnecessary by demonstrating that resistance was futile against an enemy that could replace any losses and return stronger. This was industrial warfare at its most decisive. Not brilliant generals or heroic battles, though both occurred, but systematic mobilization of resources and people that created advantages so overwhelming that tactical skill became irrelevant. The Essex-class carriers proved that in modern warfare, the factory was as important as the battlefield, the shipyard worker as critical as the combat sailor, and industrial organization as decisive as tactical genius. 24 carriers in 4 years. The number seemed impossible in 1940, implausible in 1941, necessary in 1942, achievable in 1943, routine in 1944, and decisive in 1945. The transformation from fantasy to reality occurred because thousands of people believed it could be done and organized systems to make it happen. That belief, and the organizational competence that transformed it into reality, won the Pacific War. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.